Hi, this is Section P.8, solving basic equations. For example number 1, they give us an equation and we need to solve it. So whenever you have parentheses and a number in front of the parentheses, you always want to distribute. So we end up with 7 minus 7x equals 4 plus 8x plus 7. Now we got to get all the x's on one side of the equation. I'm going to get the x's to the left side and the constants to the right, but it doesn't really matter. And I'm also going to combine these like terms. So I'm going to first subtract 7 to both sides. So I don't need to combine those because the 7's canceled. Now I got negative 7x equals 4 plus 8x. Now I'm going to move the 8x over to the left side by subtracting. Now I got negative 15x equals 4. Divide both sides by the coefficient, negative 15, to isolate the x. And that will do it. So our final answer is x equals negative 4 over 15. Example number 2. We have another equation. This one involves fractions. What I like to do with fractions when I have an equation is I like to clear them out. So the way I clear out fractions is I multiply everything by the LCD. The LCD in this case between 4 and 3 is 12. So if I multiply both sides of the equation by 12, that's going to clear out the fractions. All right, so I end up with, that's going to be 12x minus the 4 goes into 12 3 times, so I get 3x. Over here, when I distribute the 12, the 3 goes into 12 4 times, so I get minus 4x. And then I got minus 12 times 5, which is 60, equals 0. 0 times anything is 0. All right, now I can combine these like terms. Whoops, I forgot the x there. That's 12x. I missed that. Okay, now I can combine these like terms and solve for x. So 12 take away 7x is 5x. I'm going to also add 60 to both sides. All right, so that is the second to last step. And the last step is to divide both sides by the coefficient of 5. And our final answer is x equals 12. Yep, because 60 divided by 5 is 12. All right, moving on to the next example. All right. I got rid of that one because it was exactly the same as the previous example, so got rid of it. All right, for this one, we have another equation. In this case, we have the variables in the denominator. But it works the same way. We need to clear out the fractions. So the way we do that, once again, is to multiply both sides of the equation by the LCD. In this case, the LCD between x and 4x is 4x. So if you multiply both sides of the equation by 4x, on the right side, we need to distribute. You'll see that the x's cancel here, and we're left with 4 times 7, which is 28 on the left side. On the right side, when I distribute, the 4x cancels with 4x, and I'm just left with 5. Plus, over here, that's just 4x. And now we have a pretty basic equation where we just, the two-step equation, subtract 5, that's 23 equals 4x. And finally, divide by the coefficient 4. And our final answer is 23 over 4, which cannot be simplified. So we leave our answer in fraction form. The next example also has variables in the denominator. So we approach it the same exact way. We multiply everything by, or both sides of the equation by the LCD. In this case, the LCD, well, we got z plus 1 is one factor. So definitely we need z plus 1 in our denominator, in our LCD. We also need z because they all have z's over here. And the last thing we need to do is find the LCD between 4 and 5, which is 20. So our final LCD is going to be 20z, z plus 1. So once again, multiply both sides of the equation by that LCD, 20z, z plus 1, 20z, z plus 1. So when you distribute, in the first term, you got the z's are going to cancel, so you're just left with 20 parentheses z plus 1 minus the next term. You're going to cancel out the z's again. 4 goes into 25 times, so you have 5 times z plus 1. And the next term, when you distribute here, the z's cancel. 5 goes into 24 times, you get 4 times z plus 1. And on the right side, we got the z plus 1s canceling out. So that leaves us with just 20 times 20 times z. So that's going to be 400z. All right, so let's distribute. All right, so we get 20z. You could distribute. I actually have a faster way to do this. Instead of distributing, you could, if you'd like, and then combine like terms. But since z's are the same, that means all you got to do is combine the coefficients. So 20 take away 5 take away 4 is 11 z plus 1. That's because these are like terms. They all have the same variable, and so therefore you can just combine them by adding or subtracting the coefficients. In this case, 20 take away 5 take away 4 is 11, and you keep the z plus 1. So slight shortcut there. Now we distribute and solve. So we get 11z plus 11 equals 400z. Now I can subtract the 11z. And now we got 11 equals, what is that going to be? 389z, I believe. Yeah, 389. Okay. Divide by the coefficient of 389. The answer is not very nice looking, but that is the final answer. And I don't know if we can simplify that. We can check to see if 389 is divisible by 11, which it is not. So that is as far as we can go. The next equation involves a square. So let's see. It also mentions here, if there's no real solution, enter no real solution. So they're not interested in imaginary solutions, which it looks like this will have an imaginary solution, but they're not interested in that. So we are not going to consider imaginary solutions. We're going to subtract 36 to both sides. And then we're going to have x squared equals negative 36. And when you try to take the square root of a negative number, that's where you get imaginary solution. So in this case, since they don't want us to consider that, they just want us to say no real solution. At this point, whenever you're taking the square root or an even root of a negative number, you automatically get no real solution. There is a solution, but it's not real. It's imaginary. Okay, let's check the next example. So once again, same instructions, solve the equation, and if it's not real, make sure you state no real solution. In this case, we have a cube root, so we're not going to have that problem because the no real solution only occurs when you have even exponents, not odd exponents. So for a problem like this, I'll rewrite it off to the side. You first want to isolate the cube part, and that means we need to get rid of the 6. So we can do that by dividing both sides by 6. Note that you cannot distribute because of the exponent, so be careful about not distributing there because it's not allowed because of the exponent. All right, so let's see, is that 162, is that divisible by 6? It is actually. 162 divided by 6 is 27. So now we got x minus 9 cubed equals 27. Oh, that's nice. When we take the cube root of both sides to get rid of the cube root, that's going to cancel out the cube. We end up with the perfect square. 27 is a perfect cube. 27 is a perfect cube. It turns out to be 3, and that is because 3 cubed equals 27. All right, and so then our final step is to add 9. And our final answer is 12. You could also always check your answer if you want to. Plug in 12 into x. You get 12, take away 9 is 3. 3 to the third power is 27. 27 times 6 is 162. So it does check out. All right, I believe this is the last problem of the notes for this section. All right, we have another equation, but this time our exponent is a rational exponent. So the way you would solve a rational exponent equation is to isolate this x to the 5/3. So we need to subtract the 128 over. So now we have 4x to the 5/3 equals negative 128. Now we got to get rid of the 4, the coefficient, before we get rid of the exponent. So now we have x equals, let's see, 128. That would go into that 32 times. Negative 32 equals negative 32. And then we got our 5/3. All right, and now we got to raise both sides to the reciprocal exponent. In order to get rid of a 5/3 exponent, you raise both sides to the reciprocal of that exponent, which is 3/5. So the 5's cancel, the 3's cancel, you get x isolated. And this means that you're taking the 5th root of negative 32. The denominator is the index, and the numerator becomes the exponent on the outside. So that's equivalent to this. You can enter this into your calculator the way you see it, and you'll get an answer, or you can convert it into radical notation. And if you take the 5th root of negative 32, you do get negative 2, because negative 2 to the 5th power is negative 32. And now you do have to raise that to the 3rd, which is negative 8. So it turns out that x equals negative 8. And that is our final answer. And that concludes this section.